Okay, I've got two more examples to go. So I've got integral of x squared cosine x dx. Now let's take a look at this one. What do you think should be your u, and what do you think should be your dv? Well, let's go ahead and try to let u equal to x squared. So dv will be our cosine x dx. So the du should be pretty easy to do. And what's the integral of a cosine? V will equal sine x. So using integration by parts, we have uv minus v du. So x squared sine x minus v du. So 2x sine x dx. Now wait a minute, I can't actually integrate that quite just yet. But I need you guys to look at the integral that we have now and look at the integrand. It is actually a simpler integrand than the one we started out with. Now the sine and cosine, those are, you can consider them about the same level. But notice the other part of it. I started out with an x squared, now I just have a 2x. We actually have to do integration by parts one more time. So we're going to look at the integral of 2x sine x. I'm going to let u, and I'm going to call it u sub 1 here so I don't mix it up, equal to 2x, and I'm going to let dv, 1, be my sine x dx. So I'm going to have du1 equals to 2 dx, and v1 equal to, what's the integral of sine x? It's going to be negative cosine x. So be really careful when you're writing this out. Don't forget to rewrite your first part of this. This is going to be x squared sine x minus, and this whole thing is my integration by parts for this new one over here. So I need to make sure that it's minus this whole thing. So that's going to be uv, so negative 2x cosine x minus v du. So 2 times negative cosine x dx. There's a lot of sign changes going on, so be really careful about them. So these two in here cancel out, and I have a minus on the outside of this. So when I rewrite this, I have x squared sine x plus 2x cosine x minus the integral of 2 cosine x dx. In this last part now, we can integrate it. You can integrate it to cosine x easily. So once we do that, we'll have our answer. So that's minus 2 sine x. I'm done with all my integrals. I write my plus c, and that's my answer. And now notice, each of these terms that we have here, they all have a polynomial portion to it, but they decrease in their exponents. It starts out with an x squared, becomes an x, becomes a constant 2, and then we're done. So one of the tricks and the difficulties in using integration by parts is actually figuring out what should you let u equal to and what you should let dv equals to. And again, that stuff just takes a bit of practice. I know you guys don't like to hear that, but that's what you need to do. You sort of need to get familiar, and you sort of see patterns, and you notice similarities in types of problems. All right, now how about this one? What is the integral of an arctan x dx? Now I know you guys all know what the derivative is. That's the easy one, or at least I think it should be an easy one. But what is its integral? Okay, so let's work on this. So if we think of this in terms of integration by parts again, that's our u dv equals uv minus v du. I have no idea how to integrate arctan x. So that's going to be my u, because I know how to take the derivative of it, but I don't know how to find the integral of it. So kind of like that ln of x problem that I had earlier. dv will just be my dx. So du equals to 1 over 1 plus x squared dx, and v will equal to x. So plugging everything in, we're going to have uv, so x arctan x minus v du. So that's x over 1 plus x squared dx. Looks kind of scary again, but look at it. The denominator has a 1 plus x squared. The numerator has an x. If you want to, you can go ahead and do a u substitution, or in my case I'm going to call it a w substitution, and then simplify it. So if I let w equal to 1 plus x squared, dw is 2x dx, so 1/2 dw equals to x dx. So I have x arctan x minus the integral of 1/2 1 over 2w dw. And then that term you can take the integral of. And what's the integral of a 1 over 2w? I guess if you guys would like, we can rewrite this to put the 1/2 in the front and make it the integral of 1 over w. So this is minus 1/2 ln of w, which is 1 plus x squared, plus our constant c because I'm done integrating. And I don't actually need to have absolute values around my 1 plus x squared because 1 plus x squared is always positive. So we have integration by parts here. Please make sure you memorize it and know how to rewrite the terms.